Welcome to The Explainer. Today we're diving into a pretty mind-bending idea. What if the universe itself operates on a kind of hidden language?
So let's just jump right in with that question. What if the very fabric of reality, everything, from the biggest galaxy superclusters all the way down to the tiniest quantum particles, what if it all operates on a hidden set of rules? A kind of universal grammar.
For pretty much all of human history, we've been trying to crack this code. In this explainer, we're going to look at how humanity is finally learning to first read, and now, much more recently, actually begin to write in this universal language. Okay, so our first huge breakthrough in actually reading this stuff came over a century ago, and it required a totally new mathematical tool, our Rosetta Stone really, for understanding the force that shapes the entire cosmos, gravity.
So, before Einstein came along, physics was all about vectors. You can think of a vector as just a simple arrow, right? It points in one direction, describes one force, simple enough. But to describe a reality that looks different depending on who's looking at it, he needed something way more powerful. Tensors. A tensor isn't just one arrow. A better way to think of it is like a pincushion, describing all the forces and stresses at a single point from every single direction, all at once. It's a language that works no matter what your point of view is.
And what he discovered with this new language was just brilliantly simple. Using tensors, Einstein showed us that gravity isn't some mysterious force pulling us down. Nope, it's the actual geometry of space-time itself. This famous quote, it's not just poetry. It's basically the first complete sentence we were ever able to read in the universe's own language.
Okay, so we learned to read the grammar of gravity. Awesome. But fast forward to today, and scientists are using totally new mathematical dialects to read the largest structures we know of, the cosmic web.
So how do you even begin to map something that big? Well, the cosmic web is just too vast and complicated to, just look at. So scientists use this incredible method. It's called topological data analysis. They treat every galaxy like a single point of light, and then they mathematically expand a sphere around each one. As these spheres grow and overlap, they form connections, and more importantly, they enclose empty spaces. The AI then keeps track of the exact moment a hole is born, and the exact moment it gets filled back in or dies.
And all this tracking gives us something called Betty numbers. And don't worry about the name, just think of them as a unique fingerprint for the shape of the universe. This isn't just an estimate. B0 gives us a precise count of all the galaxy clusters. B1 counts the long, stringy filaments that connect them. And B2 counts those vast, empty cosmic voids. And knowing this shape, it's not just for fun. It holds major clues about dark energy and the ultimate fate of our entire cosmos.
Okay, but here's the problem. The amount of data we're talking about here is just staggering. It's like being handed a library with billions of books, all written in an alien language. There's no way a human could get through it. So to even start, we need a serious force multiplier. And that, of course, is artificial intelligence. It's become our universal translator.
And the fuel for this whole translation project? Money. Lots of it. Just in 2024, private investment in AI in the US just skyrocketed to over $109 billion. That's the kind of cash that creates the raw processing power you need to tackle data on a cosmic scale.
And all that investment, it's leading to a massive wave of adoption. We're talking nearly 4 out of 5 organizations now using AI. That means the tools, the platforms, the talent, it's all becoming way more common. And that helps even the most out-there scientific projects get off the ground.
But maybe the most important factor here, the real game changer, is cost. Accessibility. The price of using these incredibly powerful AI models has absolutely plummeted. A 280-fold drop in just under 2 years? That's insane! It's putting the keys to decoding the cosmos into the hands of way more scientists than ever before.
So what does this AI translator actually look like? Well, it uses some really cool specialized tools. First, you've got things like graph neural networks, or GNNs. These don't just see galaxies as little dots of light. No, they see the whole universe as a massive interconnected network. They understand how a galaxy's neighbors and its whole environment actually shape its life story. Then, you've got physics-informed neural networks, or PINs. And these are amazing. They literally have the laws of physics, like general relativity, baked right into their code. This makes sure their simulations are spot on, letting them connect the dots all the way from the tiniest quantum jitters right after the Big Bang to the huge galactic superclusters we see today.
Okay, so let's recap.
We figured out how to read the grammar of spacetime. We're using AI to translate the entire cosmic blueprint. So what's next? The next step was pretty much inevitable, right? We're starting to learn how to write.
And this is happening right now in the wild field of quantum metamaterials. See, for a while now, we've had what you'd call classical metamaterials, stuff engineered to do weird things, like bend light in ways you never see in nature. Think invisibility cloaks. Cool, right? But what we're talking about now is a quantum leap. Literally. Quantum metamaterials are engineered at the atomic level to actually mess with the fundamental rules of reality itself. Things like superposition and entanglement. We're not just bending light anymore. We're taking control of the very building blocks of matter and information.
And believe me, this isn't some far-off sci-fi dream. These materials are our first real concrete steps toward writing brand new physical possibilities into existence. They're the key to finally building stable qubits for powerful quantum computers. They're how we're going to create truly unhackable communication through quantum cryptography. They'll lead to sensors so unbelievably sensitive they can detect things happening at the quantum level. This whole thing, it's the foundation for the next tech revolution, maybe even for a future quantum internet.
So we've really come full circle, haven't we? We started this journey with Einstein, using tensors to read the geometry of gravity around a single star. Then we jumped to today, using AI to map the entire cosmic web. And now we're engineering materials from the atom up to write new rules for matter itself.
As our fluency in this universal grammar just keeps getting better and better, it leaves us with one last, really big question to chew on. Are we just getting better at reading a story that was already written? Or, as we make this huge leap from reading to writing, are we on the verge of becoming co-authors of the cosmos? The answer to that? Well, that's going to define everything that comes next.